Ryan Cundiff here for a Fundamentals of Physics podcast. Today I'm going to be demonstrating the experiment called the collapsing can. With just a few everyday household items, I'm going to demonstrate how to collapse an aluminum can with air pressure. The materials for this experiment are an aluminum drain can, a tablespoon, a cooking pot, tongs, and a heat source, which I'm going to be using a stove, and water. So let's get started. Initially, we need to prepare our items for the experiment. The actual reaction takes place in a very short time frame, making preparation the most important part of the experiment. First, we'll measure a tablespoon of water and pour it into an empty aluminum can, and the temperature at this point is irrelevant. Next, we'll need to apply our heat source, which is the hot stove, to the can of water. This is to raise the temperature in the can to a boil. Third, while the water in the can comes to a boil, we'll fill our cooking pot with cold water. Basically, we want to fill it up enough to be able to submerge the can when the time comes. Once we see water vapor exiting the can, we know our experiment is ready. Now we'll carefully take our tongs and pick the can up with a comfortable grip. You want to make sure you've got it comfortable because we're about to invert the can and submerge it into the cooking pot. And that's exactly what I'll do now. Watch what happens. Okay, so clearly the can collapsed almost instantaneously. Why? This is where physics comes into play. Normally, an empty can has the same air pressure inside as it does outside. However, the water vapor had already released some air before we submerged the can. Once it came in contact with the cold water, upside down as to not allow much cold water to enter, the water vapor in the can condensed, creating a partial vacuum. The substantial difference from the low pressure in the vacuum caused the normal pressure outside the can to crush it almost immediately. The vacuum is eliminated and the pressure is once again equal.